Okay, guys, now we are going to do the practical example of the concavity, where we are explaining those graphs and everything. Now we're gonna do the practical example on how do we see the concavity, how do we calculate it, and everything and sorts. So in this question we also have that they gave us here. We also have a function that they gave us. They gave us this function. They gave us this function, which is just the function of f. So they are saying determine by calculating whether f is a concave up or concave down in these specific points that they gave us there. We need to calculate the concavity in those particular points. So now, what is concavity? Concavity is where we get our second derivative. We derive the first derivative. Now we know the first derivative is where a gradient here 2 ilingana no 0, which is a stationary point, that one. But the second derivative is where we determine the point of inflection, where the inflection point is. So our concavity now at point at x is equal to 1. So number 1 is where x is equal to -3, sorry. So you need to derive first derivative, -3x² minus 6 times it's 12x, and then plus 1. This is the first derivative. Second derivative, because when looking for concavity, so this times this is -6x minus 12. Now where we find the concavity, we do our second derivative. First derivative is a point of inflection where we get the increasing and decreasing. Increasing and decreasing, it's here, but here it's where we find the concave up and concave down, the difference between the two. Hope you see it. Then from here, our substitute our x, which is -3 and -12. Then our answer here is 6. Now I hope you see now with our second derivative at x is equal to 3, it's greater than 0. If it's greater than 0, mkhulu kuno 0, so our function is concave. It's concave up. Mkhulu kuno 0, so our function is concave up at x is equal to -3. Then number 2, they're saying concavity at x is equal to -1. We've already found our second derivative, which is -6x minus 12. This is our second derivative. We substitute -1 where it's x. Then what do we get? We get -6. -6 ubani, it's less than ubani 0. This is less than 0, meaning it's a negative. 0 mkhulu with the negative numbers, where x is -1. So this means that our graph is concave down, where x is equal to -1. So a graph it's concave down where x is a -1. How do we find that? By doing the second derivative. After finding the second derivative, we substitute that specific x value. We found that at the second derivative fx is equal to -1 is equal to -6. That means that at second derivative at x is equal to -1, it's less than -6. It's smaller than ubani 0, so that's why it's concave down. Number 3, where x is equal to 0, second derivative where x is equal to, okay, let me just put the second derivative first, which is -6x minus 12, and then second derivative at x is equal to 0. Our answer here is just -12. It's just -12. This means -12 concavity where x is equal to 0. This thing is less than 1 or 0. What does this mean? It's concave down at x is equal to 0. I hope you see that one. I hope you see that one. And then now they're saying show that this question now, show that f has a point of inflection at x is equal to -2. At x is equal to -2, show that is a point of inflection. So B, point of inflection, second derivative at x is equal to 2, 0 is equal to -6 into -2 minus 12 is equal to 0. So where x is equal to -2, we're getting what? 0. I hope you see that one. Where x is equal to -2, we're getting what? 0. So f is a concave up before x is equal to -2, and also concave down after x is equal to -2. Therefore f is a point of inflection at x is equal to -2. So here this thing explains you that in the second derivative, where x is -2, where x is -2 here, in a second derivative where x is -2, this times this gives you +12, then minus this 12, then you get 0. So when it's giving it 0, it shows you that that's where things changes, that's where the inflection go. That's why we equate it to 0. That's where the point of inflection is at. So to just set something else, just to put here another point here, to calculate the point of to calculate the coordinates, calculate the coordinate of the point of inflection of a function of f. We say f prime of x is equal to 0. The alpha we solve for x. This explains this here, where now we substituted the -2 here, where we're showing that is a point of inflection, because let's say show that f has a point of inflection at x is equal to 2. Then we took this x -2, we substituted in our second derivative, which was this one. Then when we doing this, we get 0, meaning where the second derivative at x is equal to 2, that's where the inflection point is at. That's where the point of inflection is at, when the second derivative at x is equal to 2 is equal to 0. This thing explains it. Why do we equate our second derivative is equal to 0 when we want the coordinate, when we want the coordinate of point of inflection? I hope we understand that one. Thank you.